Woodpeckers may be getting brain damage from pecking wood, which adds intriguing possibilities to their role as a model species for brain trauma prevention in athletes. The structural qualities of the skull, tongue and muscles in a woodpecker have been described as an internal bike helmet, capable of successfully protecting the bird's brain from the staggering forces generated when the bird strikes a tree with its bill. The G-force of the pecking action ranges 1,000 and 2,000 grams, where a single G describes the force acting on a body as a result of acceleration at 9.80665 meters per second. A typical adventure park ride generates 4 to 5 grams, and a G-force of approximately 60 to 100 is enough to cause brain trauma in a football player. Biomechanical studies have indicated that the superb structural adaptations of the woodpecker family work perfectly to protect the brain from these forces, but until now no one had examined the brains themselves. Researchers at the Boston University School of Medicine in the U.S. examined preserved museum specimens of woodpecker brains and found protein markers that could indicate brain trauma. The result is a paper published in the journal PLOS One. Peter Cummings, one of the study's authors, points out that there have been all kinds of safety and technological advances in sports equipment based on the anatomic adaptations and biophysics of the woodpecker, assuming they don't get brain injury from pecking. The weird thing is, nobody's ever looked at a woodpecker brain to see if there is any damage. Cummings, George Farrar and Donald Selwick examined the brains of 10 woodpeckers of various species, including the downy woodpecker Picoides pubescens, and also 5 non-pecking birds which served as controls, including the red-winged blackbird Agelaius phoenicius. The birds were loaned by Boston's Field Museum and Harvard University ornithological collections. To assess whether there was any brain trauma in woodpeckers, the researchers decided to look for the accumulation of the protein tau. Tau accumulation has been linked with brain trauma injuries in football and soccer athletes. The tau protein is also a key player in the complex pathology of Alzheimer's disease. Repeated concussive events create a condition in athletes known as chronic traumatic encephalopathy, or CTE. The tau protein accumulation levels in sufferers of CTE are akin to those in sufferers of Alzheimer's. When the brain is damaged, tau collects and disrupts nerve function, cognitive, emotional, and motor function can be compromised, says Cummings. To isolate the protein, the team removed the brains of the preserved birds, carefully sectioned them into thin slices and applied a silver ion solution. Despite the relatively small sample size, there was clearly more tau accumulation present in the brains of woodpeckers than in the controls. We can't say that these woodpeckers definitely sustained brain injuries, but there is extra tau present in the woodpecker brains, which previous research has discovered is indicative of brain injury, says Farrar. Given the suite of morphological and behavioral adaptation the woodpecker displays, perhaps, there's a possibility that the tau in woodpeckers is a protective adaptation and maybe not pathological at all. Cummings says the function of the tau protein is complicated, with research published in 2017 showing that bigger accumulations of tau, known as tau bundles, have a protective rather than pathological effect. Tau buildup in the brains of healthy woodpeckers provides an intriguing avenue for further research. If the tau accumulation is a protective adaptation, is there something we can pick out to help humans with neurodegenerative diseases? The door's wide open to find out what's going on and how we can apply this to humans, concludes Cummings.